The bare PCB, or printed circuit board, is often the most expensive item on a PCB assembly bill of materials and can present a surprising number of choices for the design engineer. The basic composition is a substrate, a conducting layer, and a solder mask. This is the most common substrate, known as FR4. It's a rigid laminate composite of woven fiberglass and a flame-retardant epoxy. It's a good general-purpose substrate due to its excellent strength-to-weight ratio, dimensional stability, and relatively low cost. There are a number of other options, including high-temperature polyamide for transportation and high-temperature environments, and materials for high-frequency designs. But today we'll focus on FR4. There are still at least 4 variables for the engineer and PCB designer to evaluate. First is thickness. FR4 boards can be as thin as 0.008 inches to as thick as 0.125 inches. The standard thickness is 0.062 inches, or 1/16 of an inch thick. If you are very concerned about the weight of your final product, you can get 0.031, half as thick, for about the same price. For large boards, you might want a thicker substrate for increased rigidity. The second variable is thickness of the conducting layer. This is specified as copper weight, or ounces of copper per square foot of board. You can see the copper layer under the solder mask here. The standard is 1 ounce, about 1.4 thousandths of an inch thick, or about 1/3 as thick as a sheet of copy paper. Boards with ½ ounce to 8 ounces are readily available. The thicker the copper layer, the more current you will be able to run through the traces. The trade-off is that the traces will need to have a coarser pitch, and you won't be able to use the smallest ICs with their closely spaced pins. You'll have to specify larger components. The third variable is layer count. The most common is 2 layers, one on top and one on bottom. But we also design and manufacture a lot of single-layer boards, as well as multi-layer boards with up to 24 layers of copper sandwiched between the layers of FR4. Each additional set of layers increases the materials cost of the bare board, but makes it easier to lay out the design and achieve high component density. Since there's no impact on manufacturing cost, this trade-off can make sense when small board size is important. And finally, the fourth variable is color of the solder mask layer. The green is the most familiar, but for a little more money, you can get red, black, blue, and white, including a non-yellowing white for boards with LEDs to reflect the LED's true color without changing it. Some companies use color to differentiate prototype boards from their final product, and others use color as part of their branding. At Z-Axis, our electrical engineers and PCB designers will work with you to understand your system requirements and recommend bare board choices that best meet your needs. Contact us to learn more about our electronic design and PCB layout services.